This is my lab report on the black hole mass. Section M6. So for this lab we had to find the black hole mass using our code. We had to input this mass and the delta t, which is 1 day in seconds. Also, we had to link it to the file that gave us the star positions. And then we had to find the mass, given that the force was the gravitational force between the mass, the star, and the black hole. So we defined the position of the black hole. We got the position, the distance between the star and the black hole, and the constant of gravity. And we found the mass of the black hole, which is the magnitude of the force times the magnitude of the distance between the two objects squared divided by the gravity times the mass of the star. And we got this 2.97 times 10 to the 31. So for the what does it mean question, basically the force net perpendicular, which is the blue arrow, is equals to the change in momentum, which is perpendicular, which is the blue arrow, and also the force net is equal to the change in momentum, given the formula of momentum. And the force net parallel, right here, the red arrow, is equal to the change in momentum parallel because of our definition of momentum. However, what they mean or represent, it's different, because force net actually causes the change in momentum, and the force net is an invisible cause, and we see this force, the action of this force through the change in momentum. So the change in momentum is visible and the force is invisible. So the parallel force or change in momentum actually give us the magnitude, and the perpendicular force or change in momentum gives us the direction. For the what if question, also the gravitational force is dependent on the position of both the star and the black hole, and both of their masses, as well as the gravitational constant. If the position and the motion of the star and the black hole remain the same, and the mass of the star also remains the same, then the force and the mass of the black hole will remain the same. However, if the mass of the star is different in this simulation, then the mass of the black hole will change. Granted that the mass of the black hole is still larger than the mass of the star, and the product of both masses still has to be the same as the product of their masses in the previous simulation. Thank you so much. This was my lab.